Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at Introduction to Linear Inequalities, and here are the lesson objectives. Without much ado, let's quickly look into these. So let's start by looking at what inequality means. An inequality, it compares two quantities that are not necessarily equal. Throughout our previous lessons, we'll be looking at equations. But inequality, on the other hand, will compare two quantities that are not equal. There are four symbols we use in inequality. These symbols are, we have the less than, which is represented by this. Then the greater than. We have the less than or equal to. And then we have the greater than or equal to. So let's take them one after the other. Then we'll look at how we use them. So to start with, let's take a variable and let's let our variable be x. If you have x, which can be any value at all, if I say x is less than, let's say, a 5, then what we are simply trying to say is that x isn't a particular value, but it is a range of values that are all less than 5. So what are some numbers that are less than 5? We have 4, we have 3, we have 2, we have 1, and it goes on and on and on. The list continues. So we have 0 as well, we have -1, and then it goes on and on. Now, all these numbers here are less than 5. 4 is less than 5. Hence, it will satisfy what we've written here. 3 is less than 5. It will also satisfy x being less than 5. 2 is less than 5. So all these numbers satisfy. If we have to say x, which will be another variable, which is then greater than 5, then in that case, we are going to take numbers that are bigger than 5. You see, so with that, we can start with 6, then we go on with 7, 8, 9, and then it goes on and on and on, an endless list. That is for greater than. Now, what of less than or equal to? So we talk of less than or equal to, it is just one term that makes it different from the less than, and that is, if I say x is what, less than or equal to 5, it can include all these terms we have here. That is for this section, but then it will also include 5 as well. So with that, if I'm to clean what we have over here, we are now going to start from what, 5, because the values in that set should be not only less than, but at least one should be equal to the 5. Hence, in listing this element, we say 5 before we then go to 4, 3, 2, and then it goes on in that order. So the or equal to here makes you include the number itself to it. You see? So the same way, if you have to take x, where x is what, greater than or equal to 5, then with that, we are also going to start from 5. So 5, before listing the remaining numbers that are greater than 5. So you have 5, 6, 7, 8, and then it also goes on and on. These are the basic meaning of the 4 inequality symbols. So with that being the case, let's look at the clear-cut difference between an equation and an inequality. When you take an equation, we always have just one solution to it. There is always one number that serves as a solution to an equation. On the other hand, for an inequality, it has so many solutions. An equation also uses just an equal to sign, but an inequality has four of these signs, as we have considered. Then for an equation, it has an exact value. This even links to our first difference here. So it has an exact value, whilst an inequality has a range of values. With these differences spelled out, let's solve some few questions on inequality. Then in the last section, I'll give you one golden rule you need to know when solving inequalities. So what do we have here? It says solve x plus 4 less than 10. So we have x plus 4, and then it should be less than 10. So when it comes to solving inequalities, you just use the same set of rules we learned for equations. The only thing you need to know is your final answer is a range of values. So solving this as we would in equations, all we need to do is to move our 4 to the other side. That is using the balancing method or any other method. We have our x plus 4 minus 4 less than 10. And since we have subtracted 4 from the left hand side, we do same to the right hand side. So that this gives us an x plus 0. So less than 10 minus 4 gives us a what? A 6. It simply means for this equation to hold, we need to take the values of x that are less than 6. Let's try and then test for our solutions. So for the ranges of values of x that are less than 6, you have 5, 4, 3, 2, 1, and all the negative integers. Let's try for x, which is equal to 5, and then c. So this will simply imply our left hand side is going to give us a 5 plus 4. 5 plus 4 gives us an answer of what? 9. And is 9 less than 10? Yes, it is. So this satisfies our solution. If you take x being equal to any of the negative integers, so let's take negative 4. We have negative 4 plus 4. And that will give us what? A 0. And 0 is also less than 10. You see. But let's take x to be 6. And we know 6 doesn't satisfy this. It is not less than 6. So let's take x to be 6, and then we see. So for that, we are going to get a 6 plus 4, which is equal to a 10. Now, 10 is not less than 10. You see, so that does not satisfy our inequality. And we can see that spelled out here. It says all the values of x should be less than 6 so that we are able to satisfy. So this is inequality. You solve everything just as you would for equations. But there's a golden rule we need to know, and this is it. So the rule says when you multiply or divide both sides by a negative number, you need to reverse the inequality sign. You need to reverse the inequality sign. And that is just it. That is the golden rule. What does it mean? So let's take some questions that will require us to multiply or divide, and we'll see what it actually means. So to test out this rule, let's solve for negative 2x is greater than 6. Negative 2x is greater than 6. So we have negative 2x being greater than 6. Now, as I said, we always solve using the steps we learned in equations. So anytime you have an inequality of this form, it is all about making the x the subject. So we have negative 2x greater than 6, and we'll divide both sides by negative 2. See, so dividing both sides by negative 2, then it simply means this negative 2 cancels out this negative 2. And we have x being greater than 6 over negative 2 gives us a negative 3. But will this actually work? If you are taking x values to be greater than negative 3, an example of a number that is greater than negative 3 is actually negative 2. So if we multiply negative 2, by our x value, which we are taking to be what? A negative 2, because it is greater than negative 3. What are we going to get? We are getting a negative 4. A negative 4 is certainly not greater than 6. That makes it wrong. So what this rule is saying is, so far as we have divided by a negative number, so either division or multiplication, you see, so far as we have divided by a negative number, then what we need to do is to reverse the inequality sign, so that instead of greater than, because there is a division by negative, then we are going to change the inequality sign to less than. You see, and with that, our sign or our solution becomes x is less than negative 3. Now let's substitute another number which is less than negative 3, so we see if it will actually work. So let's take a number that is less than negative 3, and that is negative 4. So testing for negative 4, we have our negative 2 into bracket the x, which will now become a negative 4. And evaluating this, we have an 8. Now, is 8 greater than 6? Yes, it is. And that is all this rule is saying. So anytime you multiply or divide by a negative number, just change the inequality sign and you are good to go. I didn't go much into details because all the steps we need in solving inequalities are in equations. The only thing we need to note is the differences and the golden rule. I'll leave you with some exercises, but as time goes on, I'll solve more examples to enhance your understanding. So these are 4 questions, and as you can see, it says don't let the signs trick you. Know when to change when you need to. To solve these problems and then share your answers in the comment section. I do hope this lesson was helpful. Let's have beyond numbers where we learn maths the easy way. If there's any issue of concern, you can always let me know at the comment section. If this is your first time and you think this channel will be of help to you, you can always choose to subscribe. That is if you so do wish, so that anytime I release a video, you'll be notified as well. Bye for now, and do stay safe.